Welcome to this video. In this unit, we'll delve into the basics of supervised learning and more specifically into linear regression. This is a machine learning method you probably already know from other contexts, but we will look at it from a new perspective. So grab your notebooks and let's get started. In a previous lesson, we explored the fundamentals of supervised learning, where we use a target variable for prediction. This variable can fall into two categories: classification or regression. Classification deals with nominal or ordinal targets, while regression tackles numerical variables. Let's explore a practical example of regression. Imagine having a data set with salary and years of experience as value pairs. Linear regression aims to find a linear function to predict salary based on experience. This is the special case of a linear regression with one variable. But how does it work? The residual sum of squares method uses the deviation between predicted and actual values summarized over all value pairs. The regression algorithm thus minimizes this deviation and thus finding the best parameters to make our model as good as possible. In more realistic scenarios, we deal with multiple independent variables, or features, which can number in the hundreds. Linear regression extends seamlessly into this case, transforming into a hyperplane with n dimensions then. We often deal with many features, but not all matter. So to refine your model, we use the feature selection, testing each feature's impact on the target variable. If a feature doesn't contribute significantly, based on measures like so-called p-value, we can leave it out. Now let's talk about the quality of our regression model. While it is easy to train a regression model, assessing its predictive quality is crucial. We introduce here the coefficient of determination, R², which quantifies how well our model explains the variation in the data. A high R² suggests a good fit, while a low value indicates challenges, either high data variance or a mismatch with a linear model. But beware of overfitting. Just because a model fits training data well doesn't mean it performs well as on new data. We'll explore strategies to tackle overfitting, including testing model with independent data in our future lessons. And here you have it. Linear regression is a powerful tool in the world of artificial intelligence. We've journeyed from the basics of supervised learning to the nuances of linear regression with one variable expanded to multiple variables, and explored the crucial aspects of feature selection and quality metrics. Join us in the next lessons as we dive deeper into the nuances of machine learning. Until then, happy learning!